The USS Abraham Lincoln does not operate alone. Like every US aircraft carrier, it sails as the centerpiece of a carrier strike group. Surrounding it are guided missile destroyers, primarily Arleigh Burke class destroyers, equipped with one of the most advanced naval air defense systems in the world. The key system that makes this possible is the Aegis Combat System. This is an integrated radar, tracking, and missile engagement system designed specifically to defend ships against aircraft, cruise missiles, and ballistic missiles. At the heart of Aegis is the AN-SPI-1 radar. Unlike traditional rotating radars, SPI-1 uses phased array technology with 4 fixed radar panels mounted on the ship's superstructure. Instead of physically rotating, the radar beam is electronically steered. This allows continuous 360-degree coverage without interruption. Because the beam is steered electronically, it can rapidly switch between multiple targets. This is how a single destroyer can track over 100 airborne objects at the same time. The radar continuously scans, detects, and updates target positions in fractions of a second. When the USS Abraham Lincoln sails with 3 or 4 Arleigh Burke class destroyer escorts, each destroyer contributes its own radar coverage. These ships are positioned in specific formations to maximize overlapping radar fields. This creates a layered air defense shield around the carrier. For example, sea-skimming cruise missiles fly just above the water to avoid detection. Ballistic missiles, such as China's DF-21D, descend from high altitude at steep angles. Hypersonic weapons travel at extreme speeds, reducing reaction time. The SPY-1 radar is designed to handle multiple types of threats simultaneously. It can track a high-altitude ballistic trajectory while also monitoring low-altitude cruise missiles. Another major capability is Cooperative Engagement Capability, CEC. This allows ships in the strike group to share real-time radar data. If one destroyer detects a missile, that information is instantly shared with other ships. A second destroyer can then launch an interceptor even if the target is beyond its own radar horizon. This network creates what defense analysts call a single integrated air picture. Instead of operating independently, all ships function as part of one unified defensive system. Each Arleigh Burke class destroyer typically carries 90 to 96 vertical launch cells. These can hold different types of missiles, including SM-2 for air defense, SM-3 for ballistic missile defense, SM-6 for extended range and advanced threats. With 3 destroyers in formation, the strike group may have close to 300 interceptor missiles available. However, missile defense is not unlimited. A known challenge is saturation attack. This occurs when an adversary launches more missiles than the defense system can intercept at one time. Countries such as Iran, China, and Russia have developed missile strategies designed to overwhelm defenses through volume. For example, Iran operates anti-ship cruise missiles like the Noor. Russia fields cruise missiles such as Kalibra. China has developed anti-ship ballistic missiles specifically intended to target carriers at long range. The strength of the Aegis system is that it reduces the likelihood of surprise and maximizes engagement opportunities. Early detection provides additional decision time. At long detection ranges, commanders may have several minutes to assess and respond. However, emerging hypersonic weapons compress that reaction time significantly.
More ships ever built.
This is one reason the US Navy is deploying the newer AN-SPI-6 radar on newer destroyers. The SPI-6 offers greater sensitivity and improved discrimination against smaller or faster targets.